Good day, everyone. Welcome to Jamovi for Educational Research Tutorial Series, Episode 10, Repeated Measures ANOVA. What is repeated measures ANOVA? The one-way repeated measures ANOVA, or RM ANOVA, is used to assess if there is a difference in means between three or more groups where the participants are the same in each group that have been tested multiple times or under different conditions. It is the equivalent of the one-way ANOVA but for related, not independent groups, and is the extension of the dependent t-test. A repeated measures ANOVA is also referred to as a within subjects ANOVA or ANOVA for correlated samples. All these names imply the nature of the repeated measures ANOVA, that of a test to detect any overall differences between related means. The RM ANOVA makes the same assumptions as most other parametric tests. The dependent variable should be approximately normally distributed. There should be no significant outliers. Sphericity, which relates to the equality of the variances of the differences between levels of the repeated measures factor. If there is a violation in the assumption of normality, then the non-parametric equivalent Friedman's test should be considered instead. As for the violation in the assumption of sphericity, we will talk about it later. Here is our sample situation. Teacher Mina wants to determine the effect of formative reflection log on the achievement and retention of students in the lesson Newton's Law of Motion. She administered the pre-test prior to the intervention, conducted a post-test after 1 quarter, and follow-up test after 2 weeks. And here are the tasks that we will go through in this tutorial. Perform the test and check the assumptions. Interpret the results. Report the analysis. Once your dataset has been successfully imported in the Jamovi software, you're now ready to perform the test. So make sure to keep your focus on the process. Let us now begin. If we click the Analysis tab for ANOVA, we can see there the option for Repeated Measures ANOVA. But before we proceed to that, let's click first the Exploration for the descriptives. So we can conduct a test for normality through Shapiro-Wilks test, since we have first to be assured that there will be no violation in the assumption of normality. Otherwise, we will proceed to conducting the non-parametric counterpart of the RM ANOVA, which is the Friedman's test. We may also include the mean and SD, since we will be including those in the reporting. Let's take a look at the results, and we can see that there is no violation in the assumption of normality, since the p-value that we obtained is greater than 0.05. So with that, we may now proceed to conducting RM ANOVA. We have to rename first the factor to academic achievement, since it is what comprises our data. Then rename the levels that correspond to the set of data that we have. Let's have pre-test, post-test, and of course, follow-up. Let's then drag everything to the repeated measure cells. As for the effect size, partial eta squared is the most widely used. Look closely on the next steps. I will explain everything when we go to the interpretation. Let us now continue. Before we proceed to the interpretation of results, let me show you first this additional information. Here are the differences among the effect size used in ANOVA and post-hoc analysis. Just take a closer look. This information is taken from JASP Guide for Students. When it comes to interpretation of results, these are the parts that you have to pay attention to. For the results of the main statistics or repeated measures ANOVA, always look at the p-value, which should be less than 0.05 for it to be significant. Effect size is also important since it helps us understand the magnitude of differences found, whereas statistical significance examines whether the findings are likely to be due to chance. In here, the most commonly used is partial eta squared. Here's the guide for interpreting effect size for ANOVA. Let's now proceed to the assumption of sphericity. What do we mean by sphericity? ANOVAs with repeated measures are particularly susceptible to the violation of the assumption of sphericity. Sphericity is the condition where the variances of the differences between all combinations of related groups or levels are equal. Violation of sphericity is when the variances of the differences between all combinations of related groups are not equal. Sphericity can be likened to homogeneity of variances in the between subjects ANOVA. The violation of sphericity is serious for the repeated measures ANOVA, with violation causing the test to become too liberal, like an increase in the type 1 error rate. Therefore, determining whether sphericity has been violated is very important. RM ANOVA checks the assumption of sphericity using mock list test of sphericity, which you should have a p-value of greater than 0.05 for it to be significant. These test the null hypothesis that the variances of the differences are equal. In this case, since there is no violation in the sphericity, the result of mock list test will be the one that we will report. Take note that in many cases, repeated measures violate the assumption of sphericity, which can lead to type 1 error. If it happens to have a significant result of mock list test, corrections to the F statistic should be applied. The corrections that you will encounter to combat the violation of the assumption of sphericity are the greenhouse geyser and the Hohenfeld corrections. These corrections rely on estimating sphericity. The rule of thumb is this: if the greenhouse geyser value in the test of sphericity table is greater than 0.75, then you should use the value of the Hohenfeld correction. But if the greenhouse geyser value is less than 0.75, then you should use the value of the greenhouse geyser correction. Let's now proceed to post-hoc analysis. Post-hoc test is used to compare the groups pairwise using statistical correction to avoid type 1 error, where the null hypothesis could be rejected when it is in fact true due to stricter acceptance criteria. Take note that it should only be conducted when the result of the RM ANOVA is significant, otherwise it is meaningless. This is how we interpret the results. First, that you'll compare is pretest versus post-test. Then examine the p-value if it is significant with less than 0.05. Next, that you'll compare is pretest versus follow-up. Again, look at the p-value. Same goes with post-test versus follow-up. For the descriptive statistics, report values for mean and standard deviation. This analysis report follows the APA format. Provided with the tables of results for inferential statistics, descriptive statistics, the assumptions for sphericity, and the post-hoc test, this is how you should report the analysis in order. Take note of the terms in blue font and the format of reporting values in red font. The main objective of this study is to determine the effect of formative reflection log on the knowledge and retention of students in the lesson Newton's Law of Motion. The researcher used a 50-item teacher-made test measuring students' knowledge of Newton's Law of Motion. Prior to conducting the analysis, mock list test of sphericity was conducted to examine the equality of the variances of differences between levels of the repeated measures factor. The result of mock list test indicated that the assumption of sphericity was not violated, represented by the given values. The result of one-way repeated measures ANOVA revealed that there is a significant difference in the scores of students across time, represented by the given values. There is a large effect size in this analysis, represented by the given value for the partial eta squared. Post-hoc analysis using two-piece HSD showed that there is a significant difference between the pretest and the post-test, represented by the given values. Moreover, no significant difference was found between the post-test and the follow-up test, represented by the given values. These findings indicate that the knowledge of students who were exposed to the intervention increased and was retained across time. That ends this session. Thank you for watching Jamovi for Educational Research Tutorial Series. Stay tuned for the next episode. See you next time!